Okay, so types of solutions. We're going to kind of create like a big old table here so that we can display all the three different types. It does not need to be anything super fancy. Break that space up into like 3 equal parts. Okay, the first type of solution we're going to look at today is when there is no solution. No solution occurs when the two lines never intersect. Or, in other words, they are parallel. So I will show you an example just of what the lines might look like. Okay, so those two lines right there, there would be no solution. There's no place where they cross, where they share a point. They share no point. So there is no point in the world that would satisfy both of those equations, okay? So characteristics of these kinds of systems is when you graph it, you'll see that the lines are parallel. You'll notice that both lines have the same slope. Which makes sense because they're rising and running by the same amount. That's what makes them parallel. And then the other characteristic of a system like this is that they have different y-intercepts. Which would make sense because they're gonna cross the y-axis at different points. Now the next solution is the type that you're most familiar with, and that's when there is one solution. That happens when your lines are neatly crossed and they have one point where they meet. Okay, so here's what a graph might look like. Two intersecting lines. Now this point right here is where they intersect. So this is where the solution is. So this is the solution. And the solution is a point x, y, okay? So your solution will be in that form, x, y. Zoom in just a little bit. Okay. Characteristics of these types of graphs is that they're going to have different slopes. Last type of solution that you're going to see for a system is when it has infinitely many solutions. when you graph the lines, you will see that they are the same line. They're right on top of each other when you graph. And the way that I show that is I go over the line again with a different color and I make it dashed to show that it's one line on top of the other. Okay. Now the characteristics of this type of graph is that you basically have graphed the same line. And the other defining characteristics is that they have the same slope and the same y-intercept. Now you have this great table in your notes that you can use if you get stuck and you're not sure what kind of solution it is, all right? Let's try an example. Okay, so here's a system. We're going to solve by graphing. Now that first equation is set up nicely already for graphing. Okay, so our y-intercept is 2. And our slope is 1/3. So we're going to go up 1 over 3, up 1 over 3. I do highly recommend that if you're doing this on paper, that you use a ruler, because if you're not, it may look like it crosses somewhere that it doesn't actually cross. Okay, that's the first line. Now, before I can graph the second line, I need to solve for y. So, and we learned how to do this a few days ago, solving for y. So I'm going to subtract 2x from both sides. So this will be negative 6y is equal to negative 2x plus 12. Then I'll divide both sides by negative 6. And I have y is equal to 1/3 x minus 2. Now, before I graph it, let's look at the two equations. They have the same slope, so you know it's going to be either no solution or infinitely many solutions. And they have different y-intercepts. So which one do you think it's going to be? It's right here. If they have the same slope and they have a different y-intercept, then it's going to be no solution. But let's graph it and look at it anyways. So my y-intercept is negative 2. My slope is 1/3, so I'm going to go up 1 over 3 a couple times and then graph it. Okay, and you can see they never cross. They're never going to cross. They have the same slope. They're going to continue on in both directions forever and ever and ever. So this one is no solution. Okay. There is no solution. There is no ordered pair that works in both of those equations. So far, so good? Okay, let's do an example, which I'm sure you can guess what kind of example we're going to do, but let's do it anyways, just so that we have some stuff in your notes for you to look back on. Okay, I'm going to set up my coordinate plane. Okay, my first line is already ready for me. So the y-intercept is 3, and the slope is -1/2. So that means I'm going to go down 1 over 2, down 1 over 2. I'm going to graph that line. Okay. Now I'm going to go back to that second equation, and I need to solve for y before I can graph this. So I'm going to subtract 2x from both sides. I'm left with 4y is equal to -2x plus 12. Divide both sides by 4. And you get that y is equal to -1/2 x plus 3. So looking at these two equations, they are exactly the same. They have the same slope, same y-intercept, which means that they are the exact same line. So when I draw this, I'm going to do like a little dashed line over the first one just to show that there's a line on top of a line here. And in this case, every single point on that line is a solution to both equations. So this one is infinite solutions. Infinite solutions. All right. Anybody have any questions? All right, I'm going to give you the rest of the period to work on your IXL code or any IXL codes that you haven't finished yet this week. Hey,